Here's a short video to show you how the electrons will fill up the atomic orbitals in an atom. And just to show you, here's the nucleus and the various main energy levels, 1, 2, 3, and then sublevels that are associated with those energy levels. So the first main level has one orbital, 1s. The second main energy level has two sublevels, the 2s and the 2p. The third level has three suborbitals, 3s, 3p, and 3d. And as you move away from the nucleus, the energy levels increase. So let's see how the electrons fill up as the elements are shown. So hydrogen has one electron, and the electrons are being shown here as up and down arrows because electrons spin around the nucleus, and the up and down arrows are showing kind of the direction of the spin, clockwise or counterclockwise. So the first electron goes into this 1s orbital. Imagine this arrangement as being like an apartment building where there are different floors, but there's no elevator between the floors, so it takes a lot of energy to go up the stairs. So just like electrons, we'd rather stay in the one with the least amount of energy needed. That would be the lowest one to the top. So the first electron goes into the lowest orbital, 1s. The second electron for helium goes into the same 1s orbital because there's too much energy needed to go up to the 2s. So they share an orbital. And when they share, they are going to be sharing with opposite spins. So the second electron spins the opposite way, and it's shown by the down arrow. Lithium has 3 electrons, so where does that third electron go for a lithium atom? It has to go up into the 2s orbital because that's the next available orbital. That's the next lowest energy orbital available. Let's add a few more electrons. Let's look at carbon. Carbon has 6 electrons. We already have 3 electrons in our orbital diagram, so let's fill up as we've done before. The fourth one goes into the 2s as well because again it's the lowest energy orbital available. And then the 2p orbital has 1 electron in it. So where does the last electron go? So I have 5 electrons already. Well, electrons are just like first year college students. Without any Facebook and without knowing who they might room with, a first year college student would rather probably be in their own room. So that's exactly what electrons do. They spread out over orbitals that have the same energy level. So the sixth electron will fill another empty orbital in the 2p sublevel. So let's keep going. Neon has 10 electrons. What will happen to the rest of the electrons to make a neon atom? So the 7th electron goes into the last free orbital. The 8th electron has to double up because that's preferred to fill these orbitals rather than bump up to the 3s. That extra step is too much energy. It's just as well for the electron to share an orbital in the 2p. And that's what happens to the 9th and 10th electron for neon. Now I have filled 1s, 2s, and filled all my 2p orbitals. You notice the number of electrons in each orbital is 2, and the number of orbitals in the p subshells are 3 orbitals. For the d subshell I have 5 orbitals, and the s subshell I have 1 orbital. Let's go a bit further and fill up a sulfur atom with 16 electrons. What happens then? And as you predict, the next electron goes into the next lowest energy orbital available, is 3s. And if we keep going, we see that the sulfur atom fills up 2s and has 4 electrons in the 3p. Fills up 3s and has 4 electrons in the 3p. So if you notice that because the electrons like to spread out, we have unpaired electrons here. And that's how electrons are arranged when in the orbital system with filling lower energy levels before higher energy levels, and will spread out over orbitals of the same energy, and if they're sharing an orbital, they will share them with opposite spins.